Hello, I'm Joey Minani. Today I'm going to be doing a walkthrough through assignment 1B for cloud computing architecture. What this assignment is doing is you are creating a cloud-based web application that looks somewhat like this. It's a PHP application. Don't worry, you don't have to write any PHP for this. What this does is it's hosting a S3 file bucket which hosts photos and an RDS database that has 5 columns rather, where one column is a reference in the S3 bucket. Right, the rest is stored in the RDS database. The RDS database only stores the text, and the S3 bucket stores the data. We are also creating a VPC in 2 availability zones with 4 subnets, 2 being public and 2 being private, and 1 network access control list and 3 security groups. So in this assignment, first step is to create a VPC. I have a sandbox open here. I recommend you doing this in the Learner Lab for the very first time because this will take a while. So the first step is to create the VPC. So let's go ahead and do that. And you'll notice this says to use the VPC only button and not the Start VPC wizard. We don't have the Start VPC wizard, and we've only been using VPC and more in the labs, so we will keep this at VPC and more. First thing to do is to create a VPC with the naming conventions with your first initial, last name, and VPC. So we'll go ahead and do that. So for me, it'll be J Minani VPC. CIDR block, this is correct. As per this diagram here, we can see here, this VPC should be in 10.0.0.0/16. That's correct. We can leave all of this the same. 2 availability zones, we've got 1A and 1B, that's correct. We do have 2 public subnets and 2 private subnets, 1 in each. And no NAT gateways, and we want to get rid of the VPC endpoint because we only need 1 internet gateway as revealed here. So now what we need to do is also customize the subnet CIDR blocks. As we can see in this diagram here, we have 10.0.1.0/24 for the public subnet in availability zone A, 2.0 for public subnet 2, 3, and 4. So let's reflect that in here. So this is 10.0.1.0/24. Second one will be 2. And then the privates would be 3 and 4. Let's just verify this is correct. So for 1B, this is private. Yep, 4. That's all good. After we've got this, you'll notice we've got 3 root tables. Now, technically, this is wrong. We should only have 2. But we can't make that change here. We have to make that change somewhere else. So what we're going to do is create our VPC. All right. Now we can view our VPC, and I recommend to take a screenshot of your current step here because you will need this for your lab report. So at this point, we need to get rid of one of these private subnets because in the lab, we should only have 2. Here it's implied that we've got a public subnets with a public root table, and we've got the private subnets with the private root table. So what we need to do is see how this public root table is associated with 2 public subnets. Now for the private subnets, they're both associated, their individual root table. We can converge those. So what we're going to do is go into root tables. We're going to refresh this, and we can see our root tables. And notice how the public one is associated with 2 subnets. We want to reflect that change on one of these. So I'm going to arbitrarily select one of them. So I'm going to select the second one, subnet associations, and we're going to remove the subnet here. So now we can see there is no subnet association with the private 2 root. And what we can do is go ahead and delete this one. And for 1A, we can go into subnet associations and add the second private root. And for consistency, I'm going to remove all of this. And there we go. Now we've got our public and our private root tables. This is correct as per the assignment's specification. We do have an internet gateway. That's fine. That is created by default. And the first step is now complete. This is the correct VPC. And you can see there is a default root here. We can delete this if we want to, but there's no requirement to do so. So I'm going to leave that intact. Second step is to create these security groups. So what I'm going to do is go into security groups on the left, and we're going to make the first one. So this one is called, test instance SG. That's the first one. We need a name for these. So what I'm going to say is allow all traffic into the test instance for the VPC. we want to select our Jmanani VPC and inbound rules. Here, we've got all traffic from anywhere. So what I'm going to do is select all traffic and the source from anywhere in the IPv4 space. Egress rules, that can stay the same. We don't need to modify that. Let's create the group. And now we need two more. So what I'm going to do is create another one. This one is called web server SG. Allow HTTP and SSH and ICMP to the web server. Select the right VPC. We're going to add a rule. And for this one, we need HTTP and SSH from anywhere and ICMP from only the test instance. So what I'm going to do, I'm going to select HTTP from anywhere in the v4 space. I'm going to add a rule for SSH from anywhere in the IPv4 space. And finally, we're going to say ICMP, all of them from just our test instance SG, like this. In production, SSH from anywhere, this is bad. So make a comment on this in your lab report. Say that allowing SSH from anywhere, any IP address, this is a security vulnerability, provided they know the key. All right, egress rules, they can stay the same as well. We'll create this. And finally, we need our last security group called DB server SG. So this allows MySQL from web server. We can select our VPC, add an inbound rule for MySQL, and our source is the web server security group. Let's create this. And there we go. We have our security groups and what we can do to verify that we have them all. And so this is a little bit neater. Don't worry, you don't need a name here because the security group has a name. We can say VPC and it's probably the first one. So let's try that. There we go. The default, we don't really care about that. We can just leave that intact. Or if you want to remove it, feel free to. All right, moving on. We need two EC2 instances. One is serving as the web and Bastion server, and one is the test instance. So what we're going to do is go into EC2 in here. And we're going to launch an instance. And because we're lazy, I'm just going to give it this name, Bastion/web server. This can remain as default. This can remain as default. This is all default. T3 micro, that's fine. Key pair. Now you will need a key pair for this assignment. So what we are going to do is create a brand new one. PEM if you're on Mac, or Linux if you're happy to use Linux. But for me, I'm on Windows, so I'm going to use the PPK format and just call this an arbitrary name. So I'm going to call mine assignment. Let's create this key pair. And what we need to do is whenever you see VPC, it's in our VPC. Notice how in this deployment diagram, everything that we're ever going to create except for the S3 bucket is inside of the VPC. So it's pretty safe to assume if you ever see VPC, set it to your VPC. Now for the subnet, what we can do is also have a look here and notice that the web server is inside public subnet 2. So what we're going to do is assign this public subnet 2, and we can keep this as disabled because we will assign a elastic IP later. So now I'm going to select an existing security group and select our web server SG. That's fine. This can be left as default. We only need 8 GB of GP3 storage for this. And as per the lab document, the assignment document, what we are doing is we are using the bootstrap script from assignment 1A. So what I'm going to do is I already have that open here, that I'm going to copy this, make sure to copy the very first character all the way to the last one. You need all of this. So I'm going to copy that, go back into what I had before, and we're going to paste that in the user data. I'm going to make sure I've got the final P and the starting hash correct. Now we can launch this instance. Now we don't need to wait for this. We can just proceed. From here we can proceed. So what I'm going to do is assign this an IP address. Because this is a publicly facing server, it needs a public IP address to be able to access it. So what I'm going to do is go into Elastic IP, and you'll notice I'm reading along here. This is the Elastic IP we need because the public DNS will change each time the web server restarts. We don't want that. So what I'm going to do is allocate an Elastic IP, US East 1, that's correct, that's where we are. Allocate. Now we have one IP. What I'm going to do, select this one, actions, associate Elastic IP, and I'm going to select the web server instance. We don't need to choose a private IP or the reassociation checkbox. We can just straight away associate this. Now you notice if I go back into instances that this server now has an elastic IP address once we actually refresh it. There we go. So now it's got an elastic IP, meaning it will never change even if we restart the lab. Now, from here, what we can do is create our test instance, and this one's basically do it yourself. This one doesn't tell you what settings to do. It's entirely our choice. But we know whenever we see VPC, it needs to be within the VPC we created. So for this one, I'm going to call this test instance. Everything can be left as default. Key pair. This needs to be the assignment key pair for what we're going to do later. VPC. Obviously, this is within our VPC. And the subnet. Let's have a look what subnet it should be in. This test instance is in private subnet 2. So what I'm going to do is select the private subnet 2. Oh look, it's already selected for us. That's fine. We can disable this because this is actually a private server. This doesn't need a public IP address. That's fine. It still has an internet connection, don't get me wrong, but it doesn't have a public IP directly associated. So now we can select an existing security group, select our test instance SG, and that's fine. We don't need any custom data for this, and this can have the same 8 GB of GP3 storage. That's fine. Let's launch this instance. All good. Now, what we need to do is follow this guide here, which teaches us how to run a ping from the test instance to the web server instance. So if you have a look at this one, this is actually a little bit complicated. The Mac has a separate walkthrough compared to Windows. But on Windows, what we are doing is we are using something called pagent to actually allow agent forwarding. So what we essentially are doing is SSHing into the Bastion server. So by Bastion server, we mean a server that has access to all the other private servers within private subnets. So notice this one doesn't have a public IP address or a public DNS record. So technically, we can't actually SSH into this. And that's the entire point of the Bastion server. This gives us a way to access our VPC through the public internet, right? So once we SSH into here, we can SSH into here through this one, the test instance's private IP. And to test connectivity, after we're double SSH'd into the test instance, we are running an ICMP ping back to the web server. So I will demonstrate that here, but if you want, you can skip ahead. So what we have is we've got PuTTY on Windows. I'm going to select our Bastion web server. Actually, first we need pagent. It's already running. So you'll notice down here, I've got pagent already running. I will open that. And what we're going to do is we're going to add a key, and it was the key we downloaded before for the assignment. This is fine. I am going to close this. In PuTTY, I'm going to put in the public IP address of our Bastion server. In SSH, auth credentials, of course, we need the private key of the server. And this is very, very important. Inside of auth, you need to select allow agent forwarding. If you don't, when you try to SSH into test instance from the Bastion server, you'll get denied. Allow agent forwarding basically sends our private key to the other server using PuTTY as a proxy. So for our username, it's always EC2 user. And you'll notice, surely, we're in. There we go. Took a little while that time. All right, now we're in this server. What we can do is we can SSH into the test instance server with its private IP address. So what I'm going to do is SSH EC2 user at that IP. And you'll notice after we allow its fingerprint, it will just go straight through. We didn't have to provide the key, and that's what the entire point of allow agent forwarding does, and that's why we need to import the key into pagent. So now we are in this server. What we are doing is we're trying to go from our test instance, ping the web server. So what I'm going to do is run ping to the test server's private IP address. So for me, it is 10.0.2.145. Now the last number, this will be different for you, but the subnet should be the same. It should be 10.0.2. whatever in your example. It will not always be this. Same for this server here. It's working. That's good. That is exactly what should happen. Security is working. So we can exit out of this, and there we go. I'm going to leave a connection open to the web server because we will need it later. Now moving on, This is correct. That's fine. Now we need the RDS database instance. So what I'm going to do is go into our console, RDS, Aurora and RDS. And because the database needs to live in the private subnets, not subnet, subnets, what we need is a subnet group. So what I'm going to do is create a subnet group, and we're going to call it something that hints at private. So I'm just going to call it private. Whoops, private. Description, I'm not sure if this is optional, but I'm going to give it one anyway. So group of both private subnets, VPC, always our VPC. Availability zones, if you remember from what we've got up here, we're in A and B. So I will select A and B and select both of the private subnets. So I've got private 2 and private 1. Create. And now we can go into databases and we can safely create a database. So for this one, we'll see we need an RDS instance of MySQL version 8.0.42 in free tier template. Now you'll notice something interesting here. If I select MySQL, I'm going to go 8.0.42. There is no template that says free tier. This is fine, it's just a template, right? I'm just going to leave that as default, production, and we're going to select one instance. We only need one instance. As per the diagram here, there's only one instance. So one instance, DB instance identifier, what we're going to call, RDS database. Completely arbitrary, whatever you want. The lab or the assignment doesn't say what to create it. Admin is our password, and we want to manage our password. So I'm going to select a very secure password of password123, and again, password123. Now for instance configuration, as we did in the lab 6, I think, or lab 5, burstable classes, dbt3 micro is fine. And to save on costs, we are going to select GP2 and drop this all the way to minimum of 20 gigabytes, which is still too much than what we actually need. We don't want to connect an EC2 compute resource. IPv4 is fine. VPC, obviously our VPC, because this lives in this massive VPC box. DB subnet group, that should be on our private. We don't want to allow public access. It does not need a public IP. The security group, we need to select our DB server SG and deselect our default. Availability zone, there is a preference. It should be in 1A, so we will put it there. And we can disable monitoring because we don't need it. Now, we can create our database. A little bit expensive, $14.71 every month. Right, this will take a few minutes to actually start, but we can move on in this meantime. So, after we've created our RDS instance, we can create our... Oh, sorry, nope, there's one more thing we have to do in RDS. We need to install phpMyAdmin, and the reason this is because the RDS instance is in a private subnet. We can't actually access the RDS instance. We need to install phpMyAdmin on the web server EC2 instance. And the web server, if we remember from the security group, only the web server can access the MySQL running on the database. So we need to install phpMyAdmin on that. And there is a guide how to do this on the assignment 1B canvas page. I've got it pulled up already. And what we are going to do, the first step is to SSH into our EC2 instance using PuTTY. But because we are smart, we already have our PuTTY open. And what we need to do is use cd to change directory to the Apache document root. So I will do cd/var www html. What we can do is download the phpMyAdmin source files like this by right-clicking to paste or Control-V if that works for you. And now we can unzip PHP, tab, enter. And if we have a look now by ls, we have the installer file, the zip file, and the folder. Now we need to change the directory name to phpMyAdmin, so I will do mv phpMyAdmin, phpMyAdmin English to just phpMyAdmin. Enter. Now because you're smart, we're not going to use WinSCP, we're just going to use the terminal to do this. So we have a file called config.sample.inc.php that needs to be renamed to config.inc.php. Because we're smart, we know this command renames stuff. So we can do that again. So mv config... We first need to cd into phpMyAdmin. mv config.sample.inc.php to config dot config.inc.php. There we go. That's done. Now, inside of config.inc.php, we need to change the localhost to the RDS endpoint. Now, hopefully by the time we do that, the RDS endpoint would be initialized. So what I'm going to do is we're going to use the command line based tool, nano. So I'm going to use nano and type in config.inc.php, press enter, and you'll see we are using the arrow keys. We can't use the mouse here because it's all in command line. So we're going to use the arrow key to go down a bunch and try to find the host. Here it is. We found the line. So I'm going to use the arrow key to get into this where it says localhost. And now we need to change it to the RDS endpoint. So back on our other window here, what we need is the RDS endpoint. So this is still loading, but I should have an endpoint anytime now. Okay, it's done. We can go into here and we can see it's given an endpoint. Don't worry if it says backing up, that's fine. We've still got the endpoint. What we're going to do is we're going to copy this back into Putty. We're going to right click to paste, and there we go. Make sure there's no starting or trailing space. That's good. So as per what Nano says down here, we're going to do Control X. Do we want to save? Y to save, and then enter to write the file. There we go. All good. We've changed the file. Back to the lab. Oops, sorry. Let's go back to that document. And we should be able to access phpMyAdmin through the EC2 public DNS. So what we are going to do is go back to here, EC2. We want to go to our web instance. So I will select this, copy its public DNS. We will go into here, /phpMyAdmin. Now, it loads. So for this, our username and password is what we created before. So for me, it'll be admin and password 123, which is very, very secure, and you should use it as your password everywhere. So now what we're going to do is go back to here, and what we need to do is create a database. Note that it doesn't say a name of what the database should be, so we're going to call it whatever we want, but it needs to have a table called photos with these columns. So what I'm going to do is create a new database. I'm going to call this one assignment create, and inside of here we want one table with 5 columns, I believe. 1, 2, 3, 4, 5. Yep, create. Now we need to set up our database schema. So the first one is title of varchar 255, description of also varchar 255. We have creation date. Now these are kind of arbitrary because we can change them later, so I'm just going to say date for this one. Date. We have keywords and reference. So keywords also of varchar 255 and reference of varchar 255. Now let's save the table in MySQL, and what we can do from this point is go onto our network ACL. So let's move back into here, VPC and network ACLs, and we need to create a network ACL. So this one needs to have a name. The name is given to us, public subnet 2 NACL. Oops. Subnet, or sorry, VPC, always our VPC. Tags, we can leave that as default. Now we have an NACL. We need to change its inbound and outbound rules. So what the lab says is we must allow SSH traffic from anywhere so you can access the web server instance. If we have a look at the diagram up here, we can notice this NACL, make that a bit faster, this NACL only covers the public subnet 2. So an NACL is at the subnet level. The security group protects the instance level. So the NACL protects the entire subnet of public subnet 2. This NACL protects all of this, including the security group. So what we're going to do is go back to here and edit inbound rules. I'm going to add one rule for SSH. And what this one does is allows everyone, so 0.0.0.0/0, that means every IP in the IPv4 space, that's allowed. So let's go back down. From here, oops, a bit too far. We need to allow ICMP traffic only from the subnet that contains the test instance. So what subnet contains the test instance? I know based off memory that is the 10.0.4.0 subnet down here for private subnet 2. So back here, we're going to allow that. So for 2, we're going to allow ICMP, all of this from that subnet. So 10.0.4.0/24. All good. Now we need another one to allow all other necessary traffic so the photo album website is fully functional. So if we remember, how do we access a website? What protocol do we use to access websites? HTTP. We use HTTP to access websites. And HTTP uses port number 80. So we'll go add another one, 3, for HTTP. This one, also from anywhere. Now, let's save our changes. Outbound rules. We need to also edit these and allow anything going out. Because right now, by default, it blocks all traffic. So we'll add one rule to allow all egress traffic from this NACL. So now we need to actually associate it with the subnet. So we'll go into subnet associations, edit subnet associations, and put this on the subnet that it should be on, which is the public 2 subnet. Save this, and there we go. We are done. So that's what it says. These are the 3 rules that need to be created, right? But let's have a look here. If I refresh phpMyAdmin, you'll notice something. It's not loading. This will never load. And there's a very important reason for this. In networking, a port determines a conversation that a server and a client is having with each other. Now, we have open port 80, but that's just one port. It means only one conversation can happen at once. So what we need to do is add the ephemeral port range, however pronounce that word. So what I'm going to do is add a new rule called rule number 4, custom TCP, and we need the ephemeral port range to allow more than one client to access the website at the same time. So you might be wondering what other client is accessing the website at the same time. You'll be surprised. 1024 to 65535, that's our ephemeral range from anywhere. This can be a little more specific, but for now, for proof of concept, we are going to allow this. Save changes. And you'll notice it now loads. That's because we allowed the server to have multiple communications. We are loading 2 tabs at the same time. These happen on different ports under the hood, basically. So there we go. We have created our NACL, and we can move on. So functional requirements. This is actually putting the website online. So we've created the actual infrastructure. We've created everything we need. But now we need to actually make the functional requirements of the website. So the first step is to create an S3 bucket to store our photos. So I'll go to here, S3, and we will create a new bucket. General purpose is fine. Now the bucket name must be globally unique. So what I'm going to call this is probably silly bucket 9905 for no reason. Completely arbitrary name. Object ownership, disabled. Now, you'll see in this assignment, it says all objects must be publicly available. So what we are wanting to do is to disable blocking of all public access. We want to enable that. So we will allow public access by disabling block all public access. Bucket versioning, that's off. Tags, optional. And all of this can remain as default. Silly bucket 9905. Create bucket. And the next step is to add a couple of photos into this bucket, manually upload some photos onto the bucket you just created. So what I'm going to do is go into the bucket. I'm going to go into where it says objects, upload, and we are going to add some files. So here I've got 2 files. I've got city.png and stars.jpg. I will upload them both and hit upload at the bottom right. There we go. They're done. Let's have a look at one of them. So I'll go into city.png. And here we've got an object URL. So I will open this and you'll notice something. Access denied. It's public, but it's not fully public. We need a bucket policy. we need a bucket policy to allow full public read of the files in the bucket. The bucket will load, this URL will load, but the files are still not publicly accessible. So what we're going to do is in our bucket, we're going to go to general purpose buckets again, silly bucket 9905, permissions, and we need a bucket policy. So I'll go into edit here, and now we need to type a policy. Since this assignment is basically a do your own research assignment, what we have is, I have something, here we go, this here. What this does is allows public access to the bucket. It's already got a policy for you. This is the policy that we need. So what I'm going to do is I'm going to copy this. You should use this as a reference inside of your report. And what I'm going to do is paste this in our policy. And see here it says bucket name. We're going to change this to our bucket name. So for us, it is silly bucket 9905. And now we can save. There we go. So now if I try to refresh this image, you'll see it works. Now this is a big image. This will take a while to download on my pretty trash internet. Right, cool. Let's move on. Now we need to store some photo metadata in our RDS database. So what we're going to do is go back to our phpMyAdmin, go into our table. Oh, why is this table called 1? That's not right. Alright, my apologies, I have changed the name of my table. What we are going to do is click insert up the top, and now we need to insert our photo metadata. So I uploaded 2 images, one called city and one called stars. So what I'm going to do is say for title, this one's called city, description, cool city at night, date, completely arbitrary, 1st of September, keywords, city, night, colors. Reference, the reference is actually where the entire URL, including HTTPS, inside of the Amazon bucket. So I will copy this URL, go back into, phpMyAdmin, paste this here, and now we need to do the same for stars. So I'll say stars, cool galaxy, date, 3rd of September, why not? For keywords, stars, universe, space. Reference, because we are smart, we are just going to change the actual permalink to just stars. And if we remember, our link was JPG. So I will press go on this, and both of the city and the stars were inserted into the table. And it's probably worth taking a screenshot of this table right here, displaying that you have created the data inside of the photos table. So now if we go back to the assignment, we need to actually make the photo website on the EC2 server. So I already have downloaded the photo album source code. This is on the assignment 1B on Canvas. And what we need to do is modify the constants.php file. So what I'm going to do is inside of my files, inside of university, inside of my cloud computing architecture, 1B walkthrough, photo album, we have a file called constants.php. What we're going to do is we're going to open this notepad because I'm lazy. Sure. So now all of these, or rather majority of these, need to be changed. So inside of here, I'm going to change my name to Joey Manani. Student ID 105928712. Tutorial ID, I'm on a Friday at 4:30 p.m. Now the bucket name, for me, it is silly bucket 9905. And for the region, this shouldn't need to be changed. We're already in US East 1, which is North Virginia. This doesn't need to be updated either. And now for the database, since there was no requirement for what it should be called, I called mine assignment, but we need to tell PHP what it's actually called. So I will set this constant to assignment. The DB endpoint should be the endpoint of the RDS instance. So I will have to go back and copy it from phpMyAdmin because you're smart. I will copy it from here instead of going onto RDS again on Amazon. The username is admin indeed, and the password is password123. Now, the columns in our table, most of mine are intact. I've named mine title, description. I named this one date, keywords, and reference. That's fine. I'll save this file with Control S, close this, and that's all our files done. So what we are going to do now is we need to transfer all of these files onto our server. So what we are going to do is by Cyberduck on a Mac or by WinSCP on Windows, we're going to transfer those files into the Apache document root inside of a folder called COS20019, inside of another folder called a photo album. So if you have a look in constants.php again, sorry, I closed it. This is the directory structure. So inside of the Apache web root, we have COS20019. Technically, this is wrong. This should be about here. So inside of COS20019, photo album, and that should work. So if we have a look through here, COS20019, photo album, album.php. That's how that should work. But because I'm lazy and I don't want to use WinSCP and I'm adept with the terminal, I'm going to do this manually. So I'm going to go cd ... Now I'm in the Apache web root in the HTML folder. I'm going to make directory of COS20019. I'm going to cd into COS20019, and I'm going to make directory photo album. Cd into photo album again. And now I need to upload or manually create our files here. So what I'm going to do is going to say nano album.php. Going to open this file in Notepad, copy and paste that into nano, control X, Y, enter, nano constants.php. Our Notepad still has it open, so I'm going to copy that directly. Now we have a default style.css. I'm going to open this file too. Paste that here. We've got mydb.php. Oop, that's not right. Or was it? There we go, that's right. And we have our photo.php too. There we go. We've manually uploaded all of those files by using a text editor in the remote server. And now we should try to access our website with this placeholder URL. So we are trying to use the public DNS / COS20019 photo album album.php. We've got it already open here. So what I'm going to do is, because we are smart, we're just going to change the directory that we're in. So we're going to say COS20019 photo album and then album.php. Now if everything is right, oops, something went wrong. This is probably worth mentioning inside of the lab report. I made an error, base table not seen. So the photo metadata doesn't exist in our table. So what I'm going to do is I'm probably have made an error. So I'm going to have a look inside of constants.php and make sure I have done everything right. So sillybucket 9905, that's fine. Assignment, that's correct. And there we go. I forgot to change the DB photo table name. For us, this is explicitly mentioned in the document to be called photos. That's very important. Control X, Y, enter. And now if we refresh, we can see our table is rendering and all of its data is being stored inside of the RDS database except for the photo as an object. This object is stored in S3 as a permanent S3 link. Only the reference to this link, so a link, literally the link as text, is stored in the RDS bucket. There we go, that's all good. And the lab says to finally make sure to run another ping from the test instance back to the web server. That's all good. We trust that it will work again, and that's it. So you should have a screenshot of basically every step that you've done here, and that's basically it. You need to explain everything that you've done, and that should be all done. Thank you for watching. I hope this was a help. Any questions, leave them below. Thank you.